Hey guys, so in today's video, I'm gonna go over some tweaks that you can make to your printer to super tune your Z offset. A couple of problems that I've been having lately with my printers is I run three different types of hot ends. The first one is a micro Swiss all metal hot end, and it comes with a tip that looks just like this. And see if I can get this thing to focus. And the tips are awesome. They're very robust, very well machined. But the thing that I don't particularly like is how wide this angle is. So this angle is, I want to say it looks to me like it's about a 30-degree angle. And when you compare that to the stock Creality nozzle, you can see that the Creality nozzle is just sharper. So if you put one over the other, you can see that there's an angle difference there. It's not very much, but it's significant. And another thing that you notice too is that the amount of material around the tip, around the opening, is slightly more. Take this thing off of the. Is slightly more material than on the Creality tip. So this, while it doesn't seem very obvious, it does make a big difference in stringing. And I'll show you in a second what I mean. So another hot end that I run is a E3D V6 all metal hot end. And this is not an original nozzle. I'm getting the original nozzle. I just ordered it directly from E3D. This is I guess it's a knockoff that you pick up on Amazon. And same thing. So it has a similar angle to the micro Swiss hot end. So if you look there, you look down there, you can see that they look similar. And turn on the light, maybe you guys can see a little bit better. So you can see that angle is about exactly the same. So you compare that angle with the one from the Creality tip. Not sure if you guys can see that, but you see the difference in the angle? And that difference doesn't seem to be a big deal, but it is. This particular nozzle produces very clean prints with the way that it's designed. I mean, little to no stringing whatsoever. And it's the one that comes on the stock Ender 3. So I got a couple of Ender 3 V2s, and this is the type of nozzle that comes with them. And once you tune this thing, man, the prints are just awesome. But I'm going to show you guys how you can super tune your Z offset to get super clean prints, even if you're using a E3D V6 nozzle or the micro Swiss all metal hot end nozzle. Each one requires a different approach, but I'm going to show you how you can get very good prints from this style nozzle. And I'll show you what I mean here. So I got a few examples to show you. So I was having some issues with the E3D V6 hot end, printing a part that I print with no problems at all on my Ender 3 that's running the stock hot end, either with the Slice Engineering heat break or with the Bowden setup. It printed this part perfectly. But for some reason with the E3D I was having this problem, and it took me a long time to figure it out. It had nothing to do with E-steps. The E-steps were correct. I checked those. What did solve the problem for me was increasing the temperature. So I increased the temperature to 240 degrees, up from 230, and this is, I print in PETG. That's what this material is. And that solved the under extrusion issue that I was having with these with this threaded part. So after super tuning the Z offset, let me show you what it looks like. So this was the result. So you can see I got just a few little wisps in there, but no under extrusion. All the threads came out real good. I don't have any big filament that didn't stick to the side and is coming across. So all the threads are perfect. Now I want to show you the difference between this one, which is as good as you're going to get with the Micro Swiss hot end or the E3D hot end with the nozzles that they come with, compared to the stock Creality nozzle with the Bowden setup. And the reason that I'm using the Bowden to show you this is because of the long retraction distance that you can set. It acts like a syringe to suck the filament back into the nozzle. And since the nozzle angle is more than the Micro Swiss and E3D, you're not picking up any filament along the edges that collect and cause these little wisps. So here's the one printed with the stock Ender 3 hot end using using Capricorn Bowden tube. So see how there's no wisps. I think there's maybe one there on the bottom, but there's none further along the print. So today we're gonna tune up the CR10S Pro V2. It's running a Micro Swiss all metal hot end and a direct drive from Micro Swiss. So we're gonna super tune that one. I'm gonna show you the approach to dealing with that setup. So let's get started. Guys, if you're new to the channel, make sure to subscribe, turn on your notification bell, leave me some comments, and share the video with someone that you think might be interested in 3D printing or is running through some frustration with his 3D printer. Maybe I can provide some information to help them out. All right, guys, so let's get to it. All right, so let's home our printer. We're going to go to Settings. We're going to go to Move, and we're going to home it. All right. Next thing I'm going to do is I'm going to warm up the hot end so that I can take that little piece of filament out of there. From the main menu, you're going to go Temperature, Manual, and I'm just going to set it at 160. Just to warm it up so I can remove that filament. All right, so it should be hot enough. I should just be able to pick it out of there. Perfect. Now I'm going to set my temperature to 0. And then once it cools down, I'm going to go ahead and show you guys how to super tune the Z offset. So before we get started, I just loaded up a new filament, and before I do any prints, every time I use a new roll of filament, I like to verify my E-steps to make sure that my feed rate is correct. So let's start with that. I'm gonna go ahead and warm up the hot end. So I'm gonna be printing with PETG. So I'm gonna warm up this hot end to 220. And I'm also gonna raise my gantry up. Probably raise it up to 50 millimeters. And then I'm going to move it over. I'm going to move the X over to the center of the build plate. So that's 150. Oops. And then I'm going to measure off using my calipers 110 millimeters. So here's my calipers. Open it up to 110. lock it down. And I'm just going to use a piece of tape, painter's tape, and mark 110 millimeters. I'm just going to put it on top of my filament sensor. And just put the tape there. Alright, so now that my hot end is warmed up, I'm going to go ahead and extrude 100 millimeters. And to do that on the CR10S Pro V2, all you got to do is from the start menu, you're going to press on settings, you're going to press on refuel, and then you're going to select the number of millimeters that we're going to extrude. So we're going to select 100. And the menu shows you 2 extruders, but it's going to be the left one if you only have a single one. And then you can do one of 2 things. You can retract 100 millimeters or you can advance. So we're going to advance. And then what the printer is going to do is it's going to extrude 100 millimeters of filament. This little booger off of there. All right, and what we want to do is we want to keep an eye on this little piece of tape here. And it should stop 10 millimeters shy of the filament sensor. So now we're going to verify by taking our caliper and measuring this distance. So what I'm going to do is I'm just going to take it over here, put it on my filament sensor, drop it down. And so I'm over extruding by 3/4 of a millimeter. That's okay. That's good for me. So that's right where it needs to be. All right. So I'm going to go ahead and cool down the hot end because I don't need it to be that hot. So I'm going to set it to 0 and I'm going to let it cool off. Make sure there's no filament sticking out of it. And now the next thing that we need to do is we need to check our Z offset. Now when you get your CR10S Pro V2, it's going to come with one of these little feeler gauges like this. But the one that it brings is a 0.2 millimeters. But the problem with the 0.2 is that it's way too high. I mean, way too high. So there's no way to really put any filament down on the bed at 0.2 millimeters. It's just too high. We'll start with a 0.15 and then make adjustments if we need to. All right, so on the menu here, we're going to drop the Z-axis down to 0. I'm going to go over here. Right now the Z-axis is at 50. We're going to put that at 0. I'm going to bring the printer in close so you guys can see. All right, so most of these 3D printers, the method to get your Z offset right is to use a sheet of paper. The problem with using a sheet of paper is that different sheets of paper have different thicknesses. What they're meaning for you to do is to set a 0.1 millimeter, 0.1 millimeter gap. It's kind of hard to see because of the lighting. There you go, right there. So a 0.1 millimeter gap. But the problem with using a 0.1 millimeter gap is that you're going to be too low. And let me show you what I mean. So if I take this and I put it under here, it's kind of hard to see, but let me see if I can show you. Get it closer. So you see how there's a really big gap there? See that gap? So this is the one. So this, if you level your nozzle with this, what's going to happen is you're going to have a lot of strain because that nozzle is going to be dragging around all that filament, picking up molten filament along those edges, and it's going to cause you a mess of a print. So I'm going to show you what I do. So what I like to do is I'll use a 0.15, and the 0.15 puts us a lot closer to where we need to be. So I'll start off with a 0.15, and then I'll raise it a little bit. I'll raise it about 0.12 of a millimeter above whatever this value is, okay? So I'm going to just put my little gauge under here, and what I'm going to do on the printer is I'm going to bring down the Z. So I'm going to bring it down until it touches the feeler gauge. All right. So let me show you. I'll just be pressing this, and I'm going to bring it down so you guys can see. Let me lock this here. All right. So you see that reflection there? So right now I'm touching, the nozzle's touching the feeler gauge. There's no gap underneath or anything. It's touching the feeler gauge, and that's a 0.15. So let me back up here. All right, so the value that we got is negative 3.24. So off of this number, we're going to back off 0.12. So I'm going to press this. So it's going to be negative 3.12. Right? I've taken 0.12 off of this value. Right? So that's going to be my Z offset. So if you look right now, there's a tiniest little gap, 0.12 above the feeler gauge, and that's a 1.5. All right, so that's where it needs to be. So you got 0.12 over the 0.15 feeler gauge. So that's this part. So let's go ahead and remove this feeler gauge out of here. And now what we're going to do next is we're going to do a test print. But I'm going to show you the problem that you have with the default settings in Cura. So I got a couple of test prints loaded up in here. Move this off a little bit to the side. It's too bright. Come down here. Go to print, and then I'm going to print my first test square. And now this test square that I'm printing has a brim on it. And I'm going to show you the purpose of the brim here in a minute. Another thing that I ran into early on when I started 3D printing is that the default start code for these Creality 3D printers were terrible. And what I mean by terrible is once you initiate your first print, the way that the G code runs is it'll heat up the hot end to whatever the material temperature that you chose is. And then as soon as it reaches that temperature, then it starts to probe the bed. The problem with it being that way is that while it's probing the bed, it's oozing filament out of the nozzle and gumming up your bed. So it's dripping filament all over the place and it's making a mess. And then when it's finished probing, it'll come across the bed from its last probing point all the way across the bed, again oozing filament, and then it draws the purge line on the left front corner and then drags it back and then forward, or starts in the back and drags it forward. I can't remember right now. But it does it along this edge, which to me makes no sense at all. If when the printer finishes probing, it finishes probing in that corner, it should heat up the hot end in that corner. So any filament that oozes out is going to ooze out next to the build plate. And then once it reaches the max temperature for the print, then what it should do is it should wipe along this side. And then that will eliminate any filament that's oozed out during the preheating portion of the G code. So anyway, I'll make that G code available in the description. I'll include one for this CR10S Pro V2 along with the Ender 3 V2. And it would probably work just fine for the regular Enders or any 3D printer that has a 135 millimeter by 235 millimeter print bed. And all you need to do to install it is open up your Cura, go into your printer settings, and when you're looking at your printer settings, one of the little pop-up windows that'll be there on the left corner will be the start code. Just highlight everything that you have in your start code, delete it, and paste the start code that I'm going to include in the description in that place. All right, so this is that start G code, so you guys can see how it works. So right now the hot end is at 160 degrees. Now I'm printing with PETG, so PETG will not ooze at 160 degrees. But if you guys are printing with PLA, then you may have to edit the G code and lower that temperature to a point that the PLA doesn't ooze out of the nozzle. But the idea here is that the nozzle is partially preheated, but not completely preheated. So as it's doing its probing routine here, you're not going to have any filament oozing all over your bed. Oh, and don't forget to take your piece of tape off of here. All right, so now what it's doing now is it's just going to sit here in this far corner, and completely heat up the hot end to the printing temperature. Alright guys, so while this print is cooling, let's jump over to Cura and I'm going to show you how you can make the changes in Cura to get a perfect print. So here we are in Cura. Now first thing we need to do is we need to open up our model. So let's go over here to open file, and I'm going to open the single square STL file, and I'll make this available in the video description. Now you're going to make sure that you're on preview mode. Most of the time you'll probably be in this prepare mode, but we need the preview mode for this so that we can make sure that our model looks the way we expect. Next, we're going to drop down this menus here, and if you guys don't have all the settings available to you in Cura, how you can enable that is just use these three little horizontal lines here, navigate down to where it says manage setting visibility, click on that, and just make sure that you have check all selected. Close it, and then you'll have all your settings right here. Now the first change that we're going to make is in materials. Let's click on material, and the changes that we're going to make are these three down here. So we're going to change this skirt brim flow to 120%. We're going to change the prime tower flow to 120%. And the prime tower, what that is that purge that it does on the side right before it starts printing. That's what that prime tower flow is. And then lastly, we're going to change initial layer flow. Also, we're going to make that 120. And one last change is going to be here where it says build plate adhesion. Click on that. Make sure to select brim. And I like to use a brim line count of 10 because I print normally very tall objects. But if you don't need that much brim, you can reduce that. And then I'm also going to, where it says brim distance, I'm going to add a brim distance of 0.1 millimeter. And this is what we're going to use as a guide to determine if we need to make any more adjustments to our Z offset. So by adding this 0.1 millimeter gap, if this gap is not visible, then that means that we're still too low and we can go up a little bit more. If the brim comes off extremely easy, like it's completely detached, then we know we need to come down a little bit to create a little more squish to close up that gap slightly. So anyway, let's try it like this and see what happens. So I'm going to save this to disk, and then we'll head over to the machine and print it. So this is the first test print that we did. I'm going to show you why we had to make these changes in Cura. So if we look at this carefully, turn this light on so you guys can see. So if we look at this carefully, see how our brim is completely detached and it's not even holding together. And then the underside also has got a bunch of gaps and stuff. You can see that the filament didn't spread out enough. So that's the reason that we increased the initial layer flow rate along with the brim skirt flow rate and the purge line flow rate to 120. So now let's go ahead and print that model and we'll see We'll see how it comes out. So I'm going to select the one that says 120. Okay, so if you notice how high off the first layer the nozzle is, so those edges, the wall of the nozzle is not touching the filament. So only the extruded filament that's coming out of the very tip is making contact with the first layer and nothing else. So if you were a little bit lower than that, what would happen is those edges, the wall of the nozzle, will start to, as it's moving through the filament, it starts to gather the filament along the edges, and that's what causes the stringing that you cannot resolve using retraction, because it's that stringing is happening outside of the filament that's being extruded from the nozzle. So that's why setting your Z offset properly is so important. So this print here is going to finish here in a second. I'm going to let it cool off here for a few minutes and then we'll pull it off and check it. So there's that gap. Remember I was talking about that gap, that 0.1 millimeter gap. You can see it there. Alright, so let's pluck it off and compare it to the first print. So there's the brim. So you see how the brim comes off, how easy? Because of that gap. And the bottom looks really good. So let's look at it compared to the first one. So this is perfect right here. You got nice line definition. And let's see if it splits. No, it doesn't split. Perfect. So the top surface is totally shiny, which means the nozzle is not making any kind of contact. The only thing that's touching the first layer is just the filament being pushed out of the nozzle. So if we try to print an actual item, it should come out really good. I'm going to try to print a couple of little columns to do a string test. So let's print that next. And this is one that I made. I don't like the one that is included with Cura. And I'll leave a link to this one in the description if you guys want to use it. So here's the string test, and you can see all the passes that are going to go between these two little columns. So I'm going to export this to the SD card, and then we'll print it and try it out. All right, there's one more thing that we can do here, and that's to check the accuracy of our model. To do this, what you're going to need to do is go back to Cura, select your model by clicking on it, and then we're going to use the second option here that says scale. So click on scale, and that's going to give you the dimensions of this object. The dimension that we're interested in is the Z, because that's what we're working with. So here we have a Z height of 27 millimeters. So just make note of that number, and then let's go back to our model and check our model with a set of calipers. Here's the model that we printed last night. Turn the lights, we can see a little better. Excuse the lighting, guys. The sun just came out. Don't look so great. But let's set your calipers, turn your calipers on. And then we're just going to measure here. So it looks like our model is 27.1112 millimeters. So if you need this to be more spot on, let's say you need to be closer to 27 than just slightly over, you can bring your Z offset down 0.01, and that will get you closer to your 27. But this is how you can move that Z position up or down a little bit, and then that'll get you to where you need to be. All right, guys, if you found this video useful, give it a thumbs up. If you're new to the channel, consider subscribing, turn on your notification bell, leave me some comments. I love reading the comments. I do my best to get back to you guys and answer your questions as soon as I see them. And share this video with your friends that are 3D printing enthusiasts, or if they're into vapor blasting. I have a lot of videos on that subject. Here's the same part printed on my CR10S Pro V2. And this is after super tuning the Z offset. You can see it's just a couple little threads there, a few wisps, and that's it. So it prints very similar to the E3D after it was super tuned. But perfect, no under extrusion or anything. Looks really good. I'm very pleased. All right, guys, till next time, thanks for watching.